Hi, everybody. We're going to talk about synthetic division, but before we get there, we want to review what long division was. And if you remember, if I'm asked to divide the four-term polynomial on the top by the binomial on the bottom, we would go through and do this. Remember to fill in your missing degree. So here, for example, we don't have a k to the third, so we'll put that in. And then the process was, what do we multiply the divisor by to make sure that it eliminates this leading coefficient right here? Okay, so like in this case here, I would need a k to the third. And k to the third times k would be k to the fourth. K to the third times -1 would be -1k cubed. I'm going to subtract that, so I need to change my signs. I get 1k cubed. Everything else drops. And then you're going to just continue the dance, right? So I'm going to go through and say, okay, that's going to be k squared. So then I'm going to get k cubed minus k squared. We're going to change the signs. -3k squared plus 2k plus 5. -3k, etc., etc. Now, as you ask yourself, or as we go through this, ask yourself this question: what are the problems with doing this long division? I would say the most of the problems fall with the subtraction step. Because what ends up happening then is people make a subtraction and they forget to change the signs through it. And then they end up having this, you know, like here, they're like, oh, and they change the sign here. They're like, okay, change this. They forget to change the sign in the back end. And you get this remainder, you get a remainder of 6 instead of 4. But if you do that up here in the beginning, okay, that's all going to waterfall all the way through. And so if we can streamline this, life would get much, much, much better. And so that's what we're going to talk about today. So again, the problems here become your subtraction, all the writing, because let's face it, we're doing a lot of the same things over and over and over again when we, in reality, we're just kind of keeping track of what's going on. And so what happens is this. So the synthetic division looks like this. I'm going to show you once, I'm going to talk you through the steps, and then show you again. Okay? So the first things that we're going to go through and do is this. We're going to take the coefficients off of this polynomial. So I'm going to take the 3, the 8, the 5, the 10. Now notice we aren't putting any of the variables down because we're acting like we're intelligent enough to know, hey, we're starting with x to the third. If I'm starting with x to the third and I'm dividing by x, we know the answer down here is going to be something x squared. So we'll just worry about it at the end. Up over here is the divisor. Now, since we're getting rid of the x's, and this only works when you've got, you know, a coefficient of 1, and there's other ways you can get around it, but we're just starting basics here. Okay. Now, when we did the 2, remember, we always had to change the sign. So we're going to go ahead and make this negative. Now, notice -2 here is also the 0 from this binomial. And that's also important. So we're going to come back to that. And since we're always constantly eliminating the first term, notice even back here how, and if you've done this long enough, if you look back in your notes, this coefficient here is the same as this coefficient here. And so because of that, it's just like, okay, well, we know the first term here is going to be this. The first term is going to be 3x squared. It's just the way it is. If I take x cubed and divide it by x, I'm going to get 3x squared. Boom, done. I'm going to multiply this out. 3 times 2 would get me 6. In this case, -2 times 3 is giving that. And then I'm going to get 2, and that's going to be the next term I'm going to try to eliminate. And then I'm going to go -2 times 2 and get -4, and I'm going to add those up. And I'm going to do the last one. I'm going to do the -2 there, and I'm going to get 8. Now, as I said, notice here what ends up happening is that I know from before 3x cubed divided by x is going to be 3x squared. And then I'm going to have plus 2x plus 1. This over here is my remainder. So I would write it out as 3x squared plus 2x plus 1 plus 8 divided by x plus 2. But that's only if you want it to look cool. All right? So that's the process. We're just pulling the coefficients off, dropping them, and multiplying, and basically dealing with the second part. To compare it over here, I'm going to pause here for a second. Okay, needed to make some room. So let's do this one the same way. If I pull the coefficients off, I get 0, 1, 0, negative 4, 2, and 5. Give myself a little bit more space there. My 0 here is going to be 1. So watch what happens. I drop the 1, I multiply, I add, I multiply, I add, I multiply, I add, I multiply, and I add. So now I know that the divisor is going to end up being here, almost in terms of x, is going to be k to the third plus k squared minus 3k minus 1 plus 4 over k minus 1. Now notice, exact same answer, much, much, much faster. Why? Because we're streamlining it. And why do we teach you this the first way? Is because you need to know how to do the division, because this only works. I mean, if I throw a k squared up over here, this whole thing falls apart. So we need to do it differently. Okay. So your steps are this, and I'm going to walk you through this one over here. So first thing, we're going to pull up the coefficients from the polynomial. So the 3, the 4, the negative 9, and the 6. Obviously, pause as you need to. Step 2, I'm going to pull the 0 from the divisor. The 0 for the divisor is going to be negative 2. And again, if you're not sure about that, take the divisor, set it equal to 0, solve it. You're going to drop the first coefficient, so the 3 comes down. And then after that, oops, you're just going to go through and multiply and add, multiply by the 0 and then add. So I'm going to multiply it by negative 2. So I get negative 6. And I'm going to add them up. I'm going to multiply it and then add it. Multiply it, add it. So then your final answer is just going to be the remainder. So the final number is the remainder of the division, which is this one right in here. So this number down here is the remainder of the division, and the value for f, the divisor. And here's the other reason why this is cool. So what this is saying up here, if that's my function, okay, this is not only your remainder, it is also f of negative 2. So if I plugged a negative 2 into this equation, if I took f of negative 2 and I went 3 times negative 2 cubed plus 4 times negative squared minus 9 times negative 2 plus 6, my answer is negative 4. I feel like I missed something there. I'm sorry. Some of you guys are probably screaming at the screen for this. I see what I missed. This would be negative 5. This would become positive 10. Then this would be 16. See? Got to be careful with this. If I get 16 there. All right. Maybe I'll go back and fix that. We will see. You know, we'll just actually, you know what? Let's just edit that out and go from there. All right. So again, same idea. I've got the process over there. The same screen. Skip that. So here, if I'm going to divide this through, I've got, again, I'm going to divide it through by negative 2. I have the 3, I have the 8, I have the 5, I have the 10. Now, the reason why the numbers work, if you know, this is like plugging a negative 2 in as the remainder, is watch what happens. Up here, this 3 is multiplied by x 3 times, right? And so when I drop it and I multiply it, it's being multiplied through by negative 2 once. And then it's now part of this answer, and I'm multiplying that through by negative 2 again, so there's the second time, and then you get the third time, and away you go there. So then this is going to become 3x squared plus 2x plus 1, and then plus 8 over x plus 2. Okay, so that's going to be the setup there. Now, ideally, what we're going to end up doing is that this will be something set up that we're going to get remainders of zeros, because then we can use this to factor things out. And that's going to be, I think, this next slide. Yeah, the remainder theorem we talked about. Okay, so the remainder theorem we talked about how it's the same thing, that dividing by this is the same as plugging it in. And so again, that's going to make things life a little bit faster, because then we're not having to necessarily raise things to the third, fourth, fifth power. We're just constantly going through and just kind of bringing it through. So hopefully that helps get you a little bit of a setup. I'll try to link to a couple of other things here. Hopefully you'll find that helpful, and I will talk to you soon.